Hi students, in continuation of our discussions on determinants part A, in this section we will solve 5 marks questions and answers of determinants part B. As you know, the syllabus have been reduced for the year 2021 and these 5 marks questions are very important. Please attend and listen to the lecture very carefully. Now 5 marks questions. Solve the systems for linear equation. This is very important. For given equations you write. There are 3 equations. 2x plus y plus z is equal to 1 is the first equation. X minus 2y minus z equals 3 by 2 is the second equation. The third equation is 3y minus 5z equals 9. You see here in the third equation, the term of x is missing. It is not there. That means x is 0. So we have to rewrite it. In the solution, the given equations are rewritten in such a way the third equation, this is third equation, we have written 0 into x plus 3y minus 5z is equal to 9. Therefore, the matrix form is 2, 1, 1, 2, 1, 1 and the second is 1 minus 2 minus 1 and the third term is 0, 3 and minus 5. That is into x, y, z. This is x, y, z into 1. The right hand side terms are 1, 3 by 2 and 9. So this is in the form matrix A, matrix X is equal to matrix B, all in capitals. Therefore, A is given here, matrix A is written here, X and B are written here. So we have to find the value of determinant A. Determinant A is calculated using 2, 1, 1, 1 minus 2 minus 1, 0, 3 minus 5. That is equal to 2 into minus 2 into minus 5 is plus 10. Minus of minus is plus 1 into 3 is 3. So 2 into 10 plus 3 minus 1 into minus 5. That is minus 5 and 1 into 0 is 0. Minus 5 minus 1 into minus 5 and the last term is 1 into 3 is 3, 2 into 0 is 0. Therefore, the term is 3. Therefore, the determinant A equal to 34 which is not equal to 0. Hence, this is non-singular and the solution is unique. Therefore, x is equal to, it is given by the formula, x is equal to A inverse of B or 1 over A. This A inverse is 1 over A into adjoint of A into B. The inverse value A inverse is adjoint A divided by A, value of A, determinant A. Therefore, adjoint we have to calculate. Adjoint is calculated by we had to find the minors of the determinant A. So that is, you see here A11. So A11 is given by, so we have to cancel these two, the row 1 and this one and the remaining matrix, that is minus 2 minus 1, 3 minus 5 and we have to find its value of A11. Here it is 13. Similarly, we have to find the value of capital A suffix A12. That is the second element of adjoint of A. So that is minus, we have to take minus, second term is minus into, cancel this column and this row, 1 into minus 5, minus of minus 1 into 0 is 0. Therefore, it is 5. Similarly, we can calculate the value of A1, A13. A13 is 1 minus 2. A13 is 1 minus 2, 0, 3. That is equal to 3. Therefore, A21 equals, next is A21. A21 is minus, again, the here, this is A21. This you have to delete the first column and second row. We get 1, 1, 3 minus 5. That is equal to minus of minus 5 minus 3. That is equal to 8. Therefore, A22 is also calculated in similar way. Please observe and write very carefully the sign conventions for finding the elements of adjoint A. The first is plus, next is minus. So you have to start the first row plus, minus, plus. And the column wise also, this is plus, minus, plus. Then alternately, the term will be, here if you start with minus, this term will be sign convention plus, minus, plus, minus, plus. So here if you take A221, A21 is this, so it is minus. A22 is this. When this is minus, then this becomes plus here. And you follow the convention, and determinant order 2 by 2 is also given here. You also observe the original matrix or the original determinant was of the order 3 by 3. That is, A was 3 into 3. 3 rows and 3 columns. Whereas adjacents are the minors. Minors are 2 by 2. Matrices of 2 by 2. Because we are cancelling the rows and column of the cofactors. Hence, it is A22 is minus 10 here. Therefore, A23 in the similar way minus 6. A31 is 1 and A32 is 3. Therefore, A33 is 1, A33 is minus 5. So, I will repeat here for A33. A33 is here. So, this is the third row is deleted. First row is deleted, and the third column is deleted and third row is also deleted. We are deleting this row 3 and column 3, A33. So it is 2, 1, 1 minus 2. So the value is 4. A33, it is 4 minus 1. So that becomes minus 5. Therefore, we are substituting the values of the elements of adjoint A. Therefore, it is within matrix square bracket 13, 13, 5, 3, 8 minus 10 minus 6, 1, 3 minus 5. A dash, that is, we have to find the transverse of this adjoint matrix. That is, transverse means interchanging the row with column. So therefore, the row is 13, 5, 3. It becomes column 1. That is 13, 5, 3. The second row is 8 minus 10 minus 6. This becomes second column 8 minus 10 minus 6. The third row is 1, 3 minus 5. So this becomes column 1, 3 minus 5. So we have found adjoint A. And now we have to find the inverse. Inverse, because we know x is equal to a to the power of minus 1b, or 1 over a, modulus of a, adjoint a, adjoint a over determinant a into b. So on the left side is x. Therefore, it is x, y, z equals 1 over 34 into A inverse is 13, 8, 1, 5 minus 10, 3, 3 minus 6 minus 5 into AB, that is B. B is 1, 3 by 2 and 9. Here you see 1, 3 by 2 and 9. We have substituted the terms of X, matrix X, adjoint A divided by determinant A into matrix B. So this 34 we have calculated here. We have substituted. So after substitution, we get x, y, z matrix is equal to 1 by 34 into, we have to multiply matrix multiplication. This is 3 by 3 into 3 by 1. Therefore, resultant matrix multiplication will be 3 by 1. Therefore, 1 by 34 into 13 into 1 is 13. Then 8 into 3 by 2 is 12. Plus 1 into 9 is 9. So the first row 1 into column 1. We have got here 13 plus 12 plus 9. Then row 2 into column 1. That is 5 into 1 is 5 minus 10 into 3 divided by 2 is minus 15. Then 3 into 9 is 27. Then row 3 is 3 minus 6 minus 5, that is 3 minus 3 into 3 is 9 and minus 45. So if you simplify further, we get 1 by 34 into 34, 17 and minus 15. That is equal to 1 by 2. That is 34 into 34. 34 gets cancelled and we get 1. Then 17 by 34 is 1 by 2. And minus 51 by 34 is minus 3 by 2. Therefore, equating the entries of matrix X, that is X, Y, Z, and matrix B, that is on the right hand side, 1, half and minus 32, we get X is equal to 1. That is, this X is equal to 1, Y is equal to half, and Z is equal to minus 3 by 2. Problem number 2. X minus Y plus Z is equal to 4. That is the first equation. Second equation, 2x plus y minus 3z equal to 0. Third equation, x plus y plus z. The given equations are reproduced as it is in the answer part. So the matrix form of these equations are within square bracket, that is A. 1 minus 1, 1, row 1, row 2, 2, 1 minus 3, row 3, 1, 1, 1. This is matrix A. And matrix capital X is X, Y, Z. That is also within square brackets. On the right hand side, we have 4, 0, 2. Let us see the order of these matrices. The first matrix A is 3 by 3 as there are 3 rows and 3 columns. The next matrix X is 3 by 1, that is 3 rows. X is 1 row, Y is 1 row, Z is 1 row, and column is X, Y, Z, 1 column. Similarly, B is 3 rows, 4, 0, 2, that is 3 by 1. So this is form AX equals B, and then this AXB already told you. So we have to expand the first row along the first row. So the determinant A equals to 1. 1 is, this is the first element A11, which starts with plus into, delete these rows, you get 1 of minus 3 into minus of minus 3 is plus 3. 1 plus 3 minus, the next item is top here minus, and minus of minus 1, minus of minus 1 into this, you delete this column and you get 2 into 1 is 2, minus of minus is plus 3 into 1, so plus 3. Then and then the last third one is this one and this one, delete this first row and third column, you get 2 into 1 is 2, minus 1 is minus 1, that is equal to 10. If you simplify this addition, we get 2. So, sorry, we get 10. 10 is not equal to 0. Hence, it is not a singular and solution is unique. Therefore, that is equal to, now solution is given by x is equal to A inverse of B, or A inverse is adjoint of A divided by matrix A into B. So now next part is calculate A inverse or find out the adjoint A. This adjoint A, this is within bracket, we have to find by calculating all the minors and cofactors. So minors A11 is here. It will be A11 will be 1 minus 3 1 1, that is equal to 4. A12 is cancel these two first row and second column, you get 2 1 minus 3 1. So it will be minus 1 because it is a second term. So we have to alternate between plus or minus. First is plus, next is minus. So it is 2 minus 3 1 1, that is equal to minus 5. Therefore, A13 is this. A13, you cancel this and this. We get 2 1 1. So the value is 1. Therefore, A21 is this one, first term here. Here you cancel this row and the second row. You get minus 1 1 1 1. So therefore, we get minus 1 into minus 1 minus 1 minus, and minus is outside. A21 is minus outside. Therefore, it is 2. Please be thorough with the sign conventions of matrices. Otherwise, all problems will be wrong. So, A22 is this part. So, A22 we get this one and the row 1 and column 2 will be cancelled. You get 2 minus 3 1 1. Sorry, this is 2 1 is this row 2 is cancelled and column 2. Row 2 and column 2 gets cancelled. You get 1 1 1 1. That is equal to 0. A2 is here and 3 is here. So this row 2 and column 3 get cancelled. You get 1 minus 1 1 1. Simplifying, we get minus 2. Therefore A31 is here. So first column, row 3 and column 1 get cancelled. You get minus 1 1 1 minus 3. So that is 3 minus into minus is plus, 3 minus 1. You get 2. So A32 is here. You see 32 is here. 3 row and second column get cancelled. You get 1 1 2 minus 3. So its value is starting with minus and it is value is 5. Now A33, so it is multiplier factor is plus into 3 3 column 3 row 3. You get 1 minus 1 2 and 1. You get where the result as 3. So we have found all the elements of the adjoint matrix. So adjoint A is equal to 4 minus 1 1, 4 minus 5 1, 2 0 minus 2, 2 5 3. That is inverse. Inverse, we have to take inverse. So it is 4 minus 5, 202, 20 minus 2 and 253. Therefore, putting the values in equation 1, we get, this is the equation 1 here, that is x is equal to A inverse B, that is equal to 1 over determinant A into adjoint of A into B. We get xyz on the left hand side equals inverse A inverse is 1 by 10, that is, this is the value 10, that is determinant A is 10, 1 over 10 into this matrix adjoint A 422 minus 505 1 minus 2 3, and the right hand side we have 402. So as it is, we have substituted in this equation, and we get further 1 by 10. Then it is a matrix multiplication, row into column, 4 into 4 16, 2 into 0 0, 2 into 2 4. That is the items in the first. Then second row into first column, minus 5 into 4, minus 20, 0 into 0 0, 5 into 2 10. So we get here minus 10, minus 20 plus 10. Then third row here is 1 into 4 is 4, minus 2 into 0 is 0, 3 into 2 is 6. So we get total 10. So we will simplify. 1 by 10 into 20 minus 10, 10. So divided by 10. 20 divided by 10 is 10. Minus 10 divided by 10 is minus 1. And 10 divided by 10 is 1. So therefore, comparing x is equal to 2, y is equal to minus 1 and z is equal to 1. This is the answer. Next we will take. Problem number 3. 3x plus 3y plus 3z is equal to 5. X minus 2y plus z is equal to minus 4. 3x minus y 2 minus 2z is equal to 3. So as usual, we will write terms, coefficient of unknown factors, x, y, z. So 2, 3, 3, 1 minus 2 minus 1, 3 minus 1 minus 2, x, y, z as usual, unknown factors. And on the right hand side, coefficient b, that is 5 minus 4 and 3. Now, so we have to find the determinant A with these values, and we will calculate it as 40. So 40 is not 0, so unique solution is unique, and x is given by x is equal to a to the ax to the power of minus 1 b, that is equal to adjoint A by determinant A into b. Therefore, that is equal to, now we have to calculate each element of the adjoint matrix. First, so 2 plus here, plus cancel this first row and first column, we get minus 2, 1 minus 2. So that is become minus 2 into minus 2 plus 4, minus into minus 1 is 1. So it becomes 5. Similarly, you can calculate. The next item is minus here. Here we started with plus and this is minus. So this is for second column and first row. This is first row, second column. That becomes 1, 1, 3 minus 2. So that is value is 5. So similarly 1, 3. 1, 3 is this time plus. So first row and third column get cancelled. You get 1 minus 2, 3 minus 1. So that is also 5. A21. A21 is this item. So you cancel this column, second column and second row. Therefore it is 2, 3, 3 minus 2. So the value is 3. Therefore A22 is here. So second column, second row. Therefore it is 2, 3, 3 minus 2. As I told you, its value is minus 13. Then A23 is second column, second row, third column. So you get 3, 3 minus 1. So that value is simplified as 11. And A31, A31 is this item. So you cancel this column, first column and third row. You get 3, 3 minus 2, 1. That its value is 9. Therefore, A32 is this. So second, third row and second column get deleted. You get 2, 3, 1, 1. And its value is 1. A33 is this item. So you third row cancel and third column also you delete. So you get 2, 3, 1 minus 2. So that is minus 4 minus 3. That is equal to minus 7. So adjoint A is you write as it is. So whatever elements we got, 5, 5, 5. First row is 5, 5, 5. Second row is 3 minus 13 and 11. And third row is 9, 1, 9 minus 7. We have written and we have to find the transpose of this. We have to transpose. That is, rows should be interchanged with the column. So 5, 5, 5, row 1 is 5, 5, 5, becomes column 1, 5, 5, 5. Row 2 is 3 minus 13, 11. It becomes column 3 minus 13, 11. And row 3 is 9, 1 minus 7. And it becomes column 9, 1 minus 7. So we have found the transpose of the adjoint A. We know the solution for x is given by adjoint A by determinant A into B. We will substitute the values. Therefore, 1 by determinant A is here, determinant A is 40. So we will put 1 by 40 into this matrix A as it is into B. B is here in the given equation. It's a 5 minus 4, 3. We have put it. Now we have to do multiplication of matrix A into matrix B. Matrix A is a 3 by 3 matrix. Matrix B is 3 by 1. Hence resultant will be 3 by 1. So let us do it. So 1 by 40, 5 into 5 is 25 plus 3 into minus 4 is minus 12 and 9 into 3 is plus 27. Simplifying we get 40. Then row 2 into column 1, that is 5 into 5, 25, minus into minus plus is 4 into 13, 52, 3 into 1 is 3. So we get 80. And the third row is 5 into 5 is 25, minus 44 and minus 21. We get value as minus 40. Simplifying, that is dividing this by 140, we get 40 by 40 is 1, 80 by 40 is 2, minus 40 by 40 is minus 1. Therefore, this should be compared with x, y, z. So therefore, we on the left hand side we have x, y, z. This is x, y, z is equal to 1, 2, 3. Comparing the elements of left hand side matrix with the right hand side matrix, we get x is equal to 1, y is equal to 2 and z is equal to minus 1. These are the results. Next problem. Given is x minus y plus 2z is equal to 7 and 3x plus 4y minus 5z is equal to minus 5 and 2x minus y plus 3z is equal to 12. Solution. As it is, you write coefficient of x, y, z as matrix A, that is 1, minus 1, 2. That is 1, minus 1, 2. And the second row is 3, 4 and minus 5. Third equation is 2, minus 1 and plus 3. And variables are, that is unknown factors are x, y, z, that is written as a matrix. And right hand side B is 7, minus 5, 12. Now we have to find the determinant A. determinant A as it is we have copied and we have simplified the value. So first element expanding by row 1, it is 1 into plus 1 into 4 into 3 is 12 minus of minus 5 is plus into minus 5 is minus 5. Then the second term is minus of minus 1 into, you cancel this, 3 into 3 is 9, minus 5, minus into minus is plus, 5 into 2 is 10. So the third item is, third element in row 1 is 2. So this is 2 into 2 plus is that 2 into 3, 4, 2, 1. That is 3 into 4 is 12. Sorry, 3, 4, 2, 1. 3 into minus 1 is minus 3. Minus 4 into 2 is minus 8. Minus 11. It becomes, is simplifying, we get 4. 4 is not 0, hence it is a non-singular and the solution is unique and it is given by the relationship x is equal to A inverse B. So A inverse is adjoint A by determinant A into B. Let it be equation 1. Therefore, to find the adjoint of A, first we have to determine the elements of the pre-transpose matrix. So we get A11. A11 is, you just see plus into 4 minus 5 minus 1, 3. So its value is 7, simplifying. Therefore, A12 is this. So you delete this first row and second column. You get 3 minus 5, 2 and 3. You get minus of 9 plus 10. That is equal to minus 19. So A13, that is the third element. You delete the first row and third column. You get 3, 4, 2 minus 1 and the value is minus 11. Therefore, A21 is this, A21. So it starts with minus. So you delete this first column and second row. You get minus 1, 2, minus 1, 3. So be careful and write it meticulously. A11 is plus and A12 is minus and A13 is plus and A21 is minus. A21 is here minus. So we get the value 1. So A22 will be, if this is minus, this becomes plus. So it is plus 1, 2. If you cancel this and this, you get 1, 2, 2, 3. So 3 minus 4 is minus 1. Therefore, A23. Next is A23. 2 second row, third column. So you get 1 minus 1, 2 minus 1. So it is equal to minus of minus 1 plus 2 minus 1. So you be careful, start with plus minus A11, in this order only you write. Then it will be very easy to write plus minus like that. So it will be minus of minus plus 1 equal to minus 1. So next is A31, this. So it is plus minus here plus. So it is plus here. So A31 is, you can delete this first column and third row. You get minus 1, 2, 4, 5. So because this is plus, next item will be minus here. So A32 will be minus. So first, third row and second column. So 1, 2, 3 minus 5. That is equal to minus of minus 5 minus 6 is equal to 11. A33, the last item is, so this is plus minus plus. So it is plus. So you cancel this row, third row and third column. You get 1 minus 1 and 3, 4. And value is 7. Therefore, adjoint, we have to write all the elements before transposition. So therefore it is 7 minus 19, 11. First 3 items. Then A21, 1 minus 1 minus 1. 1 minus 1 minus 1. And the last row is A31, minus 3, 11 and 7. This is written and we have to take the transpose. You see the dash here, and we have to take transpose. That means rows should be changed to columns. 7 minus 19 minus 11 here column. 1 minus 1 minus 1. 1 minus 1 minus 1. and then minus 3, 11 and 7. So we have transposed this matrix A and we got adjoint A. This is matrix for adjoint A. Now we have to substitute it in the equation or the expression. X is equal to A to the power of minus 1 into B. A to the power of minus 1 is adjoint A divided by A into B. So that can be written as X is XYZ on the left hand side matrix, equal sign as it is. Adjoint A. Adjoint is A is 7, 1, minus 3, minus 19, minus 1, 11, minus 11, minus 1, plus 7. So it is copied here. And 1/4. The determinant A value is 1 by 4. That is 1 by A is 1 by 4 into B is 7 minus 5, 12. It is in the given equation. So let us find here. So xyz is equal to 1 by 4 into, this is a multiplication of two matrices, that is matrix 3 by 3 into 3 by 1. This is 3 by 1. So we have to multiply the respective elements with the respective columns. 7 into 7, 1 into minus 5, minus 3 into 12, minus 36. This is written in first row. Then minus 19 into 7, minus 133. Minus 1 into minus 5 is plus 5. 11 into 12 is 132. It is written. Second row is written. Third row is minus 11 into 7, minus 77. Minus 1 into minus 5 is plus 5. And 7 into 12 is 84. Now we have to add these elements. So we get 1 by 4 into 49 minus 41 is 8. Minus 133 plus 132 is minus 1 plus 5 is 4. So it is 4. Minus 77 plus 84 is 7 plus 5 is 12. So that has to be divided outside by a scalar factor divided by 4. 8 by 4 is 2, 4 by 4 is 1, 12 by 4 is 3. So therefore it has to be compared with x, y, z. Therefore x is equal to 2, y is equal to 1 and z is equal to 3. In the right hand side you please write matrix x, y, z. Okay, in your book. This somehow it has missed here. Therefore x is equal to 2, y is equal to 1 and z is equal to 3. Next. So given equations are written here. 3x minus 2y plus 3z is equal to 8. So therefore the system equation can be written in as usual AXB, and we can calculate the value of A. Here it comes as minus 17, which is not equal to 0. Hence it is a non-singular and so its inverse exists. Now we have to write A, we have to calculate A11 plus and then to A12 and A13 as minus 1, minus 8 and minus 10. And then A21 is minus 5, A22 is minus 6 and A23 is 1. And A31 is minus 1, A32 is plus 9 and A33 is plus 7. You please calculate in your books and copy and verify the answer. Okay, so A inverse, we can write these elements as equals minus 1 by 17. See, this is minus of 1 by 17 into matrix minus 1, minus 8, minus 10, minus 5, minus 6 and 1. And minus 1, 9 and 7. These are transposed. Okay. So we have written minus 1 here, minus 8 in column and minus 10. We have skipped one step, but you write it meticulously. So minus 5 is the second column, minus 5, minus 6 and plus 1 here. And the third row, minus 1, 9 and 7 are coming in third column. So that is A inverse. Therefore, x is equal to A inverse of B. That is equal to minus of 1 by 17. The same matrix written here and multiplied by B. 814. B is given here. 814. Copied from the above. So now we have to do the multiplication of two matrices. Row into column. Therefore, x, y, z is equal to minus of 1 by 17. This is equal to minus 1 into 8, minus 8, minus 5, minus 4. That is minus 17. Then minus 64, minus 6 and plus 36. You get minus 34. Then 10 into 8 is minus 80. 1 into 1 is 1, 81 and 28. We get minus 51. So the this, if we simplify, we get 1 by 17 into 17. Minus in minus is plus 1. Minus into minus is plus. So 34 by 17 is 2. Minus into minus is plus 51 by 17. That is 3. Therefore, x is equal to 1, y is equal to 2 and z is equal to 3 by comparing the elements of left hand side matrix and the right hand side matrix. That is the solution. Question number 7. The sum of three numbers is 6. If we multiply third number by 3 and add second number to it, we get 11. By adding first and third numbers, we get double and second number. Represent it algebraically and find the numbers using matrix method. Let the numbers be, the first number be x, second number be y, and third number be z. Therefore, we get x plus y plus z is equal to 6. It is given as 6. So, if we multiply the third number, that is z by 3, and add to the second number, that is y, we get 11. Therefore, y plus 3z is equal to 11. And it is also given, by adding the first and third numbers, we get double the second number. Therefore, x plus z is equal to 2y or x minus 2y plus z is equal to 0. This equation is written in the format A, that is 1, 1, 1. Here 1, 1, 1. Therefore, here 0, x is 0, 0, 1 and 3. There is no x term here, so it is taken as 0. Therefore, here in this equation, we write 1 minus 2 and plus 1. And B is 6, 11 and 0. X is x, y, z, the variables. So, therefore, determinant A is equal to, we calculate here as 9, which is not equal to 0. Hence, it is non-singular and the unique solution exists. Now we find adjoint A by usual method. Here we get A11 as 7, A12 as minus of minus 3, that is equal to 3, and A13 is equal to minus 1. You please write in detail. Okay, values I have for simplified I have given so that you can do copy and calculate yourself. This example number 7. So A21 is 3, A22 is equal to 0, A23 equals 3. And A31 is equal to 2, A32 is equal to minus 3, A33 is equal to 1. So therefore, adjoint A before transposition is 7, 3 and minus 1. This is column. This is 7, 3. The row becomes column 7, 3 minus 1. And this row 3, 0 and 3 become 3, 0, 3. And the third row becomes third column 2, minus 3 and 1. You please note here. Observe and note. Therefore, A inverse is adjoint A by A. Therefore, it is 732, 303, minus 3, minus 1, 3, 1 divided by 9. We have found here the value as 9. Therefore, x is equal to A inverse of B. A inverse is 1 by 9 into 732, 30 minus 3, 1, minus 1, 3, 1, 6, 11, 0. So if you multiply this, we get 1 by 9 of 9, 18, 27. You please multiply row by column. First row, first column, second row, first column, third row, first column. You get 9, 18, 27, and divided by 9 we get 1, 2, 3. Therefore, it is x is equal to 1, y is equal to 2, and z is equal to 3. So given equation is here. Here the matrix itself has given find A inverse using A, solve the system of equations. He has given three equations and he has given the same thing as repeated. They have copied. Okay. 1, 1 minus 2 it is given here. Therefore, given matrix is given. You write 2 minus 3, 5, 3, 2 minus 4, 1, 1, 1. It is given here. And then we have to find A inverse, and the total is equal to minus 1. That is not 0. Hence, it is a non-singular and A inverse exists. So, A inverse is given by adjoint A divided by determinant A. Therefore, to find determinant A, we have to calculate each element. So, A11 is equal to 0, A12 is equal to 2, and A13 is equal to 1. So A21 is equal to minus 1, A22 is equal to minus 9, and A23 is equal to minus 5. Therefore, A31 is equal to plus of 12 minus 10, that is equal to 2. A32 is equal to minus of minus 8 minus 15, 23. A33 is equal to plus into 4 plus 9, 13. Therefore, adjoint A is transposition of these elements. That is, the row is converted into column 0 to 1, minus 1, minus 9, minus 5, this one. The third row 2, 23 and 30. So we have transposed, that is interchange rows with column. So we get A inverse as adjoint A by A, that is 1 by minus 1. Minus 1 is here, that is equal to 0 minus 1, 2, 2 minus 9, 23, 1 minus 5, 13. That is equal to 0, 1 transposition. And that is dividing by minus 1. So 0 by minus 1 is 0. Minus 1 by minus 1 is plus 1. 2 by minus 1 is minus 2. 2 by minus 1 is minus 2. Minus 9 by minus 1 is plus 9. 23 by minus 1 is minus 23. 1 by 1 is minus 1. Minus 5 by minus 1 is 5. 13 by minus 1 is minus 13. Let it be equation 2. The given equations are repeated and matrix form also we have written here. That is the given A, this is A, this is X, and this is B, and the solution is X is equal to A inverse B. That is equal to X is equal to A inverse, this one calculated, we have calculated A inverse. Therefore, we simply multiply because we have already divided here the adjoint A by A inverse. So it is, we have to do the multiplication. That is equal to 0 minus 5 plus 6 minus 22 minus 45 and 69 plus 69. Then minus 1 into 11 is minus 11 minus 25 and plus 39. This is the value, and simplifying we get 1, 2, 3, and hence x is equal to 1, y is equal to 2, and z is equal to 3. That is the answer. Question number 8. Here, the cost of 4 kgs of onion is 4 kg onion, 3 kg wheat, and 2 kg cost is 60. The cost of 2 kg onion, 4 kg wheat, and 6 kg rice is 90. The cost of 6 kg onion, 2 kg wheat, and 3 kg rice is 70. It is given. Find the cost of each item per kg by matrix method. Let us do it. Solve it. Let X be the price of onion, and Y be the price of wheat, and Z be the price of rice per kg in rupees. Therefore, 4x plus 3y plus 2z is equal to 60. It is given. So the next item is 2 kg onion. 2x plus 2y plus 3z is equal to plus 6z. Sorry, 2x plus 4y plus 6z is equal to 90. Similarly, we can write the third equation. 6x plus 2y plus 3z is equal to 70. Therefore, we can write in the matrix form 4, 3, 2, 2, 4, 6, 6, 2, 3 into x, y, z equals the right hand side 60, 90, 90 all in matrix. This is 3 by 3 matrix. This is 3 by 1 matrix. This is 3 by 1 matrix. Therefore, we have to find by using the formula Ax is equal to B, that is A is equal to, we have got matrix 4, 3, 2, 2, 4, 6, 6, 2, 3. So 4 into 12 minus 12 is 0. 3 minus 3 into 2, 6, 6, 3. That is 6 minus 36, 2 into 4 minus 24. That is equal to 90 minus 40 equals 50, which is not 0. Hence, the matrix is a non-singular and a unique solution exists. It is given, it is A minus 1 exists and unique solution is x into a to the power of minus 1. So we calculate each element a12 is equal to 0, a12 is minus 6 and minus 30 and a13 is minus 20. A21 is minus 5, A22 is 0 and A23 is 2. By usual expanding by row method, we get that is minus calculating the cofactors and minus. You get A31 10, A32 20, minus 20 and A3 is 10. Therefore, adjoint FA. We substitute these elements 0, 30 and minus 20. 5, minus 5, 0 and 10. Then 10 minus 20, 10. So, we will transpose. You see the dash here and transpose. That is interchange rows by columns. 0, 30 minus 20. Minus 5, 0, 10. 10 minus 20, 10. Therefore, the solution is given by x is equal to A inverse of B. Therefore, we can write x as a matrix x, y, z, and A as the adjoint of A divided by determinant A. So, determinant A we have found here as 50. You see here it is 50. 1 by 50 into the same matrix into B. B is 60, 90, 70. So, now we have to do matrix multiplication of 3 by 3 matrix into 3 by 1. So, we get 1 by 50, 0 into 60 is 0, minus 5 into 90, 450, that is 10 into 70, 700, then 30 into 60 is 1800, 0, and minus 20 into 70 is minus 1400, minus 20 into 60 is minus 1200, 10 into 90 is 900, 10 into 70 is 700. Simply adding each item, each row, we get 250, 400, 400. That is 1 by 50 into 250, 400, 400. We get x, y, z on the left hand side equals 5. 250 by 50 is 5. 400 by 50 is 8. 400 by 50 is 8. Therefore, x is equal to 5, 8 and 8. That is the answer. The cost of onion is rupees 5 per kg, cost of wheat is rupees 8 per kg, and cost of rice is rupees 8 per kg.